So what I want to look at now is what happens when we have more than one circle, so maybe two circles. And I've called the topic intersecting circles, but really they might not be intersecting. So there's three different situations of how the circles might interact with each other. So the first situation, which isn't very interesting, is that the circles miss each other. So there's two circles, they don't intersect. We have the first circle here, they don't have to be the same size. One small circle, one big circle. The little circle has a radius of R1 and a centre P1. And the big circle has a radius of R2 and a centre P2. And really all we care about is how do we know if this is what the picture looks like? Well, it's all to do with the radiuses. If you look at the distance between the centre of circle 1 and the centre of circle 2, that distance from P1 to P2 is definitely bigger than radius 1 plus radius 2, because you've got all this gap in the middle as well. So that's true if it's a miss, if the circles don't intersect each other, and it's not very interesting. So, on to the second situation, which is that the circles touch. Now, there's two ways this can happen. The first way is that they touch externally, so they touch on the outside, something like that. So again, I've drawn one little circle, one big circle. We don't know if they're the same size or not, depends on the question. We have the centre of circle 1, P1, and the centre of circle 2, P2. We have the radius 1 and the radius 2. And if they touch just at one point externally, just there, then what's true is that the distance from P1, the centre of circle 1, to the centre of circle 2, P2, that distance is the radius 1 plus the radius 2. Just by looking at the picture, it has to be like that, doesn't it? What we also know is that if they touch externally like that, there's a tangent that's a tangent to this circle and to this circle, both at the same time. So we call it a common tangent. And it's perpendicular to this radius, it's also perpendicular to this radius. So in other words, it's perpendicular to this line joining the two centres together. The second way that circles can touch is internally. So the picture might look something like this. So we have, I suppose you have to have a big circle and a small circle if they're to touch internally. Here's where they touch just there, just that one point, and then they move away again like that. I've circle 1, a little one, so centre P1 and radius R1. And circle 2, the big one, so centre P2 and radius R2. And again, we have this common tangent here that touches both circles at this point where they touch. And if this is the case, it's a little more tricky to figure out what's going on. You really have to draw a slightly more accurate picture and try and figure out from your own picture what's going on with the radiuses and the centres. In this case, the way I've drawn it, we could certainly say this, that the distance from P1 to P2 is radius 2, which is all the way from here to here, take away radius 1, which is this bit here. So what you're left with is that distance in between P1 and P2. So that's what I've said there. But it could be that this little circle actually goes through the centre P2. Or it could be that it goes around the other side of P2 like that. So you'll have to look at the picture and figure out for yourselves what the situation is for each question, if they touch internally. And again, this is called the common tangent over here. And then the third situation, if we have two circles, is that they cut each other. So there we go. And if they cut, again I've drawn one small and one big, but they could both be the same size. If they cut each other, it means they intersect here and here in two places. I've drawn the line between the centres, P1 and P2. I've drawn in the radius R1, which goes from the centre all the way to here, and R2, which goes from the centre all the way to here. So we can definitely say this. We can definitely say the distance from P1 to P2 is less than radius 1 plus radius 2. We can't say much more than that yet, but we can certainly say that. Again, there's this line here that cuts through both these 2 points. It's not a tangent, but it is a chord. So we'd call it a common chord. It's a chord to both circles at the same time. And it's perpendicular to this line joining the two centres together. So let's do an example here together. And I'm just going to pick one of those situations. I'm just going to pick one where they're touching externally. But let's try and do this example together. And then for other types of questions, draw the picture and try and figure out from the picture what's going on. It's all the same types of methods that we've used for different questions. So the question says, show that the circles S1, S for circle obviously, x squared plus y squared minus 2x minus 6y plus 8 equals 0. And circle 2, S2, x squared plus y squared minus 12x minus 16y plus 68 equals 0. Show that those two circles touch externally. And then we have to find the point of contact, find where they touch, and find the equation of their common tangent through that point. So, first step, we've got to show they touch externally. I'm going to draw a picture like we do for every single circle question. And to draw the picture, because they've said show that they touch externally, I've assumed that they do touch externally, just so I can draw a picture. Now, ignore this for a second. And I'm going to try and put everything into the picture that I know. So circle 1, I need the centre. Well, divide this by minus 2, 1. Divide this by minus 2, 3. Find the centre of this circle. So divide this by minus 2, 6. Divide this by minus 2, 8. Let's find the radiuses of both of them. I know I've marked them in, but here it is over here. Radius 1 is the square root of g squared, 1, plus f squared, 9, minus c, so minus 8. And that's the square root of 2. And the radius 2 is the square root of g squared, 36, plus f squared, 64, minus c, so minus 68. And that works out to be root 32, or 4 root 2. So I've marked them in already. The square root of 2, radius 1, and 4 root 2 is radius 2. Now, what are we trying to show? We're trying to show that these circles touch externally. And if that's the case, you can see in the picture the distance from P1, that centre, to P2, that centre, is this radius plus this radius. So, let's give it a go. Let's find the distance between these two centres. So the distance formula, let me leave this up here. The distance formula, x2, 6, minus x1, 1, squared, plus y2, 8, minus y1, 3, squared. So that's the square root of 5 squared is 25, so the 5 squared is 25, so root 50, which is 5 root 2. And look, r1 is root 2, r2 is 4 root 2, root 2 plus 4 root 2 is 5 root 2. So this distance between the centres is radius 1 plus radius 2. So, therefore they touch externally. Now make sure you say this bit here in the exam. Make sure you spell out exactly what it is you've just done. Make that clear. Now we've got to try and find this point here, and then find the equation of this tangent here. So let's find this point first. And what you can see from the picture now is that this point here divides the centres in the ratio 1 is to 4, because this is root 2 and this is 4 root 2, so it's the ratio 1 is to 4. So we're going to use our internal division formula from last year, from the line. And we're going to divide those two centres, 1, 3 and 6, 8, internally in the ratio 1 is to 4. So you can use the formula from your tables book here, or you can do it the way I do it on the board by just kind of crossing over. You're saying 1 by the 6 and 4 by the 1 over 1 plus 4. And 1 by the 8 plus 4 by the 3 over 1 plus 4. There it is there. Sorry. And when you tidy that up, that point of contact is the point 24. So that is, let me slide this down here. That's this point here, the point 24. So we're trying to find the equation of this tangent. It's a line. If you want the equation of a line, you need a point, got it, and a slope. Well, look at the picture. I've already said that this line here, this tangent, is perpendicular to this line here between the two centres. So let's find the slope of this line, and then flip it over and change the sign to get the slope of this one. So, slide it back up there. The slope from between the two centres, y2 minus y1 over x2 minus x1. So 5 over 5, which is 1. So the slope of the tangent, well, flip this over, it's still 1 and change the sign, minus 1. So now we have a point, we have a slope, so let's find the equation. So you can use whatever method you want for this. I'm using the formula from the tables book. Y minus y1 is m bracket x minus x1, so y minus 4 equals minus 1 bracket x minus 2. And we tidy it up. Y minus 4 is minus x plus 2, so x plus y minus 6 equals 0. And there's our equation of our tangent. Job done.